Welcome to this revision burst on sequences. So, a sequence is a list of numbers that follows a rule. An example is the one that's coming up on screen now. So maybe while it's coming up, you can think about what we have to do to get from one term to the next. Each number in the list is called a term. So 27 is one of the terms in the list, 15 is another term in the list. And we talk about the terms based on their position in the sequence. So the first term, 7, is known as the first term. So 11 would be the second term, 15 would be the third term, and so on. We also need to have a look at what happens as we go along the sequence. So a lot of you will have probably noticed that you have to add on 4 to get from one term to the next term. So this plus 4 is what we call the term-to-term rule for this sequence. So a term-to-term rule is the term that you have to add on to get from one term to the next. Generate the first 5 terms of the sequence that has the term-to-term rule, subtract 9, and starts at 24. So, first 5 terms of this sequence, we get the first one for free. It says it starts at 24, so we write that one down. What do we have to do to get to the next one? We just subtract 9, it tells us in the question. So, take away 9 from 24, and I get 15. So, that's the first and second terms. Why don't we just number where we're expecting the third, fourth, and fifth to turn up, and we just keep subtracting 9, writing down what we get each time, and then subtracting 9 again until we've got 5 numbers written down in this sequence. Okay, it's your turn. Here are some questions. Try as many as you can in the next 5 minutes. Okay, how did you do? Let's go through some answers. So, question 1, part A, you should have got 6, 10, 14, 18 and 22. Part B, 2, 4, 8, 16 and 32. Part C, 10, 7, 4, 1 and -2. Part D, 22, 18, 14, 10 and 6. And part E, 16, 8, 4, 2 and 1. Question 2 is going back the other way. So for part A, you should have got that you start at 7 and then add 5. Part B, you start at 3 and then multiply by 2. Part C, you start at 100 and then subtract 9. Part D, you start at 1 and then divide by 2. Part E, start at 11 and then multiply by -2 each time. In question 3, I asked some people on Twitter for some answers. There are a lot of different answers you could have got. Just some of them are this one, 2, 4, 6, 10, 16, 26, 42, where the term-to-term rule is add the previous two terms together. This one, 2, 4, 16, 256, is where you square the previous term to get the next one. And this one is an interesting one. The term-to-term rule is multiply by 2. I think lots of people would get that one. And this one is an interesting one. It is the number of letters in successive words of the song, "Oh, When the Saints Go Marching In." Sequences can come from all sorts of places. Okay, part 2, we've got to look at another type of rule. We looked at term-to-term rules before. Now we're looking at position-to-term rules. So this sequence that we saw earlier, exactly the same one coming up on the screen there. 7, 11, 15, 19, 23 and 27 and so on. The term-to-term rule is start at 7 and add 4. Sequences like this one also have a position-to-term rule. And this relates each term with its position in the sequence. The position is just what we spoke about earlier when we call the first term the first term. The second term is in position 2. The third term is in the third position. The fourth term is in position 4 and so on. So for this sequence, the position to term rule is 4n plus 3. And if we were working backwards here, if we were using that rule, that position to term rule, to get the sequence, we would have to pick a number for n and substitute that into that expression 4n plus 3 and work out what the answer is. N is the position number. So for the first term in the sequence, n would be 1. So we can work out 4 times 1 plus 3, and that's what gives us the number 7 as the first term in this sequence. For the second term in the sequence, n is 2. So 4 times 2 and then add 3 gives us 11. And for the third term, we say n is 3. So 4 times 3 is 12 plus 3 is 15. And we carry on like this all the way through until we've got all the terms that we want. The position to term rule is often also called the nth term. And that's because we're working out the term that goes in any position along the sequence. So here's an example. Generate the first 5 terms of the sequence 5n minus 2. So what we do is for the first number in the list, we say n is 1, and that means we've got to do 5 times 1, then subtract 2, and that gives us the answer 3. For the second number in the list, n is 2, so we multiply 5 by 2 and then subtract 2 from that to get 8, and so on throughout the list. So the third number, n is 3, work it out. For the fourth number, n is 3, substitute in, work out the answer, and for the last one in the list there, for the fifth one in the list, n is 5. So 5 times 5 is 25, subtract 2 is 23. And what if the question asked us to go for the 100th term as well? If we were using the term-to-term rule, we'd have to just carry on and generate the 6th, 7th, 8th, 9th, all the way up to the 99th term. But with the position-to-term rule, or the nth term, we can go straight to the 100th position, just by substituting in 100 for n. So in this case, we're going to do 5 times 100, then subtract 2, and that gives us the answer 498. So we've gone straight to the 100th term without having to do all the ones in between. If I wanted to generate the term 2n, I would say for the first one, n is 1, so 2 times 1 gives me 2, and then I would do the same thing going through until I'd got all the terms I wanted. So I've got to add 2 each time here. That's the term-to-term rule. Notice that the term-to-term rule is the same as the number in front of the n, so we call that the coefficient of n. So for 5n, we do 5 times 1, and then 5 times 2, and then 5 times 3, and so on, and we get this sequence here. Look at that, it's the 5 times table, and the one before was just the 2 times table. So what are we going to get if we work out the sequence given by 7n? We'll get the 7 times table, yes. So can we use this to help us work out something slightly more complicated? So what about this one, 3, 5, 7, 9, 11, underneath the 2 times table there? What do you notice about it? Well, it has exactly the same term-to-term rule, so this is going to involve 2n somehow. But 2n gives us the 2 times table in the top row of the table there. But each of the terms in the new sequence, 3, 5, 7, 9, and 11, is one more than the corresponding term in the 2 times table. So we can take 2n and add 1. In the 5 times table, 5, 10, 15, 20, and 25, if we have this sequence underneath, 6, 11, 16, 21, and 26, that's the 5 times table as well, but adjusted up 1. Each term has had 1 added to it. So we can say that this is not 5n, but it's 5n plus 1, because we've got a plus 1 to each of the terms in the 5 times table. We could do the same with any other times table. 8, 15, 22, 29, 36, and so on. The difference between each of those terms is 7, so it's going to start with 7n, but each of the terms in that sequence is 1 more than each term in the 7 times table. So the nth term for it would be 7n plus 1. If I've got something like 2n plus 1, the number in front of the n there, the coefficient of n, is the same as the term-to-term rule. So if you want to work out that number, work out the term-to-term rule and put it in front of the n. And the number that we have at the end, in this case plus 1, is just the adjustment, is what we have to do to each number in the times table given by the first number you wrote down in front of the n, to turn it into the sequence you actually want. Your turn again. Try out these questions and get as many as possible done before the timer runs out in 5 minutes. Okay, it's answers time again. For question 1, part A, you should have written 12 for the first term, 52 for the fifth term, and 1002 for the 100th term. For part B, you should have written 9 for the first term, 107 for the fifth, and 207 for the 100th. The first term of part C is 5.5, the fifth term is 30, and the 100th term is 55. Part D, the first term is -1, the fifth term is -17, and the 100th term is -397. And then for part E, the first term is 12, the fifth term is 0, and the 100th term is -285. In question 2, for part A, the nth term is 5n minus 3. For part B, the nth term is -3n plus 18. Part C, you should have got -8n plus 28. Part D, it's 0.5n plus 3 or half n plus 3, either way is fine. And for part E is 2.5n plus 1 or 2.5n plus 1 or any equivalent fraction in front of the n there. And then part 3, hopefully you noticed that first sequence is just the square numbers. So the nth term would be n squared. And the second sequence, each number is just one more than each of the numbers in the n squared sequence. So the sequence is n squared plus 1. One more thing I need to show you here. Sequences can come from pictures or real life scenarios. Remember we came across the song lyrics earlier. Another example is this. If I've got 3 patterns here made of black and white tiles, you might be asked to draw pattern 4. Got a column of a black tile, a white tile, and a black tile with another black tile to the right of it being added on each time. So we can draw pattern 4 by drawing pattern 3 and then the extra bit on at the end there. The next part of a question might ask you how many black tiles there are in the 5th pattern. So what we could do here is work out how many black tiles there are in all the patterns that we've got so far, and then see what we are doing to get from each one to the next. So we're adding 3 on each time. So to get to pattern 5, we just need to add 3 on. So in this case, it's 16. So part C, how many black tiles are there in the nth pattern? This is asking you to work out the nth term. So we know we're adding on 3 each time. So the nth term is going to start off with 3n. But what do we need to do to each term in the 3n sequence to get to the sequence we've actually got here? Remember, the sequence given by 3n is just a 3 times table, and every number in the pattern that we've got so far is 1 more than the number in the 3 times table. So we're going to have 3n plus 1. Okay, here are some exam style questions. You have another 5 minutes to go through these, and then we'll look at the answers. Okay, let's go through the answers. For question 1, part A, the first two terms of the sequence are 2 and 7. For part B, yes, 62 is a term in that sequence because every term in the sequence is 3 less than a multiple of 5, and 62 is 3 less than a multiple of 5. For question 2, the nth term of this sequence can be found by finding the term to term rule, putting that in front of n, and then working out what we need to add on each time to make it the correct sequence. So the final answer is 4n plus 7. Question 3, part A, the 10th term of that sequence is 65. And for part B, the nth term is 7n minus 5, which we get by working out what we need to add on each time. That's how you get the 7 in front of the n, and then working out how much we need to adjust the sequence 7n by to get the sequence we've been given in the question. So the final answer is 7n minus 5. Part 4, a pattern of tiles. Pattern number 4 looks like this, and there are 6n plus 3 tiles needed for pattern n. So for pattern 20, that's 123 tiles. And in part C, Ash is not correct if we work out an nth term for the black tiles this time and plug in 6 for n because we're talking about the 6th term.